And make sure that's what's happening. Yes. Good. All right. Well, let's start with a little review like we tried to do yesterday, like we did yesterday. Just calculating slopes, right? If you're looking at a graph, you can count the squares. Your eyes overrun. Some stuff out of the way right here. What's the change in the y value divided by the change in the x value? Vertical change versus horizontal change. Then we had a slope formula, right? Describing that change is really the difference between the y values. I've got 2 points, which I sort of abstractly, generically, I say label point 1, point 2, right? The difference in the y values tells you how much the y value has changed, and the difference in the x values tells you how much the x value has changed. How we can calculate those two, calculate our slope value if we know 2 points. So we did a few of these yesterday, just kind of to warm up, and some of us still had some issues with the, I'll say, arithmetic, okay? So let's say we've got a couple points. And, all right, I've got these 2 points. And I want to figure out what is the slope of the line that goes through those 2 points. So we're going to plug them into that formula. Here's where I asked you to do this yesterday and waited to see what kind of answers you came up with, and had a few too many that weren't correct, I guess, the way I wanted to put that. So let's plug them into this formula here. And in particular, I purposely put in some negative values here. I'm assuming that's kind of where we had our problems with the calculations yesterday. If you didn't get them right, subtracting negatives, turning them into addition. So first got to make sure I get my y values on the top, right? So you got to go grab the y value, and it doesn't matter which one you call point 1 or point 2. It works itself out either way. So I could say, well, this y value here, -7 minus this y value, -6. So notice it's across the points, right? Both y values, not like within. Don't do x minus y or something like that. Now I started here with this, with the y value from this point, so I have to start with the x value from this point in my denominator. So 2 minus a -9. That's just setting that up. Now do the math. What did I come up with? -7 minus 6 more. This is like we did first chapter on the number line, right? I'm out at -7. I'm going to subtract 6 more. I get the -13. Subtracting a negative is the same as adding, right? So that really turns into 2 plus 9, 11. All right, so the slope of the line between those 2 points is a -13/11. Good. Right. Now I'm going to put a couple points up here again, ask you to do it. All right. You get started. I'm going to wait a minute. All right. Plus 6, huh? -7, 4, 6, -2. Can you set that up, use the formula, and find the slope of the line between those 2 points? I'm going to stand here a minute. Maybe even sit. One more trying to get in here. Good. Yeah. Hopefully this setup isn't too difficult. Hello, Christina. I think I let you in there.
Sorry, my wife is working. So.
Let's see. So the difference in the y values. I'll start here again. You could have started the other way around if you prefer. But 4 minus -2. Right? 4 minus a negative. I started here for y, so I have to start here for x. If I cross them, if I get them mixed up, if I start here for y, but here for x, I'm going to get like the opposite sign. That's exactly what happens. You get the wrong sign. So here I'll do -7 minus 6. I'm looking at 13 today. Now, do the math, huh? Subtracting a negative. Gotta emphasize this because something went wrong yesterday. That subtracting a negative, taking away a negative is turning positive. So that's really 4 plus 2. Hope you got this. -7, -6 more, -13. Maybe I'd put that out front. -6 over 13. All right, hope you got that, huh? Hope that's working for you. Getting that minus minus. That's kind of a spot that, every class somebody folks have trouble with that. Get it mixed up. Okay. All right. Good idea to just do that a little bit. Practice regularly. Okay, then kind of went through that presentation, kind of plotted points to draw a line, and said, oh, look, the slope of the line is the same as this thing in the equation. So we put something up there like this. How about this? Y equals 1/3 x plus 2. When it's in this shape or form, y equals this stuff over here. Notice that here's sort of the formula or mold for that shape. And it's called the slope-intercept form because that m is the m we've been talking about all along. That means our slope value is this number right here, multiplying the x. And the y-intercept is that extra number that's up there attached, up or down the b. So here we would say our slope is 1/3. And our y-intercept is the 0.02. X is always 0, right? We're on the y-axis, and the y value is 2. With that information, we can graph this line. I know that's 1 point. I can start from that point on the line. Right? 0.2. And now I can use my slope, right? Rise over run, to find a second point. It's saying if I go up 1, and I go over 3, there's another point there on this line. Go up 1, over 3, another point on that line. That's how we can use that information in that equation to rather easily come up with 2 points. I try to avoid saying that word easy, but hopefully you get comfortable with the idea of pulling that information out of the equation. So there's a graph of that equation, right? Take out the slope, take out the y-intercept. Positive slope number, we expect it to be going uphill. Positive slope on that line. You want the other way around, huh? Oops, don't forget your x, Steve. You guys do that sometimes too. All right, y equals -3/5 x plus 4. Now let's graph this by identifying the slope and the y-intercept. Well, that value that multiplies the x, -3/5. And 0, so 4 there means x is 0, y is a 4. You can see that. If I put in a 0 for x, that cancels out, and I get y equals 4. Yeah. You can calculate that. All right, so 0, 4, there's a starting point we can use. 1, 2, 3, 4. And using the slope, now it's a negative slope. A negative comes from a division of positive divided by negative or vice versa. So you've got to decide to make one of them negative and one of them positive. Quick review here. I know we did this all yesterday, but so I'm going to make it -3 over +5. So my rise is really going 3 down. So from my starting point, I always got to have a known starting point here. 1, 2, 3 down and over 5. 1, 2, 3, 4, 5. Get a second point, and I could connect the dots, find a line if I could hit this point. All right. And sort of made the point yesterday, if it's not in that slope-intercept form, you might have to rearrange, solve it for y. Solve this formula for y. Remember, that's why we did that. Rearrange it so that you get the mx plus b on the other side. I did some examples yesterday from our text, and I thought I had some better ones pulled up. I lost my spot on my page. But it's not unusual to see that an equation in sort of this order, where there's, well, I know it's always going to be at least this much, and then it changes for every hour or something like that. So the b plus mx, that's just switching the order, right? You want to look for that other variable that's over there in the equation. There's your x value, whatever it is, for context. And so that number that's multiplying the variable, that's your slope number. Yeah. Okay. Slope is your rate of change. I also tried to make the point, like the cost equals, oh, let's say 25 plus, let's say hours, 5 for every hour. What are the units of that slope? What are we comparing? We're coming up with a cost in terms of hours. This is really, let's say dollars per hour. Those are the units of that slope. We can take them right from the context of the problem. Or notice it's the y over the x. Those are the units of that rate of change. The y value is going to come to the amount of dollars here is going to change based on how many hours. Or, miles per hour. I was writing an equation, describing my distance in miles in terms of how fast I was going. So here, what's my distance in terms of how many hours have I been traveling, right? Miles per hour. So the units of that slope, 50 miles per hour, right? How fast I'm traveling, that rate. That's just a little side discussion there. One more of these graphs. I didn't do one like this yesterday, just want to be sure I point it out as we talk about it. Here's an equation, y equals 2x. Can we use the slope and the y-intercept to graph that? Well, there's a number multiplying the x there. My slope is a 2. And I always say, let's make this look like a fraction. So I see the rise over the run, 2 over 1. Well, what's the y-intercept? It's a 0 that we don't bother to write. Okay? So 0, 0. When x is 0, y is 0. When we were just plotting this using points, I made the point that this shape of equation always goes through the origin. That extra number up there kind of shifts your line up or down, really. And if I put in, oh, here's my slope. It says here if I go up 2, I go over 1, right? So there's the second point, up 2 over 1. But it goes through the origin. Plus a 0, we don't bother to write it. That was the point of that example, just wanted to do one like that. All right. Eventually, you'll be given a choice of how you want to graph a line, the equation. the line that goes with a particular equation. So what do we have right now? What do we have choices to work with, right? Well, we can just plot points, right? Do a table of values. If, you know, and that works pretty well for either form. Plot points or use the intercepts. And that's when you choose to stick in a 0 for the x and see, do the solve for the other letter and see what the y value will be. And if we're putting in a 0 for x, that means we're somewhere on the y-axis here. That's a y-intercept. And we put in a 0 for y and solve that equation to see what the x value would be. And that would be somewhere on the x-axis. And that's the kind that works pretty well for this shape equation, especially if, gee, these numbers will both divide nicely into that one. Doesn't always happen, especially in, I say, a real world problem, but most of our practice problems will work out that way for you. You can see if I put in a 0 for the x, right, divide by 2 and y is a 3. If I put in a 0 for the y, it goes away, right? Divide by 3 and the x is 2. So I could find the intercepts. So that's one way to graph. Another way to graph. Well, if I've got an equation that's in this shape, now I know another way to graph it. I know my slope value, I know my y-intercept. I can plot that y-intercept point and go from there with a slope to find the second point. The last things we kind of want to recognize as far as graphing, what if I just get one that says y equals 3 or x equals -1? These are those unusual or special cases, put it that way, right? Y is always 3, no matter what x value. Y is always 3. Scribbling there, but we'll still avoid. Y is always 3. That's what the equation of a horizontal line might look like. X is always -1, no matter what y value you think of. X is always -1. Again, not very neat, sorry, but a vertical line. This is the one, you know, you've got to keep them straight somehow. If you can make yourself sort of think it through and plot a couple of points if you get confused. X is, and so there's what the equation of a vertical line might look like. All right. So you have choices for how you might want to graph a line. Excuse me, sit down for a second. Whew. All right, on to our next. Suddenly got winded. Hope I'm not getting too sick. All right, let's see. And there, I drew 2 nice lines next to each other. They're supposed to look parallel, right? Parallel lines. Well, what quality that we've been talking about do they share, right? What's the same about them? How about that slope value, right? They're both leaning the same amount, right? That's sort of one definition, at least in our context here, of parallel lines. They have the same slope. So I could count squares and figure out the slopes of both of those lines, but they would be the same slopes. So if we have a couple of equations for 2 different lines, we'll be asked to decide whether or not they are parallel lines. Well, we're going to put them both into this shape, slope-intercept form, right? And compare the m values. Do they have the same slope value? distance here. How about, of course, you got to hide it, make it a little harder to see. If you're looking at two equations that are in this shape, gee, just look at the slope values. Are they the same? If they're the same slope, you got to make sure they're not going through the same intercept, otherwise they're the same line, right? They got to have the same slope but different intercepts to be two distinct lines. But if they have the same slope and different intercepts, they'll be parallel. So here's one equation, and the other one I'm going to write is y equals negative 2/5 x minus 4. So, well, I'm not sure. This one's not in the right shape yet. So here I go, I'm going to go through that process of solving for y. I'll subtract the x's. All right, so that's going to leave 5y. And I'll put the x's in front, and then plus a 5 over there. And now to get y, I'll divide both sides by 5. Everything gets divided by 5. So I got y equals negative 2/5 x plus a 1 simplifies, right? Well, now I have these two in this slope-intercept form, and I can compare negative 2/5, negative 2/5. That means they're parallel, and this one is going through a y-intercept of 0, 1, and this is going through 0, negative 4. So they're not the same line, right? Spread out a little bit. Let's happen to be going downhill. So that's our technique for dealing with parallel lines. We just have to put them in this form that allows us to compare those slope values. If they are the same without the same intercept, they're parallel lines. And yes, you can kind of expect that at least one of them is going to be in this other shape. So you have to do a little work to get it there. It's not just immediately obvious. Okay. Next. So that's the one big piece today. Parallel lines, same slope. Well, what's that other sort of special situation, I suppose, we can come up with for two lines? And see if I can make this look at all good. All right, what's the idea here? I think I did that pretty well. Those are supposed to look like perpendicular lines. Now, so they have a special relationship between their slopes also. And sort of the first thing most folks think of is like, oh, one's positive and one's negative, right? Well, that's true, right? Unless they're actually horizontal and vertical, that's one to know, those are perpendicular, right? But here we can't actually use the slopes because one is undefined and one is 0, so we can't really compare them like we're going to here. But yes, as long as they're not just the axes, one will be a positive and one will be a negative. But you can imagine perhaps here's one that's got a slope of about a 1/2, right? And a slope of a negative 1/2, well, that's just shallow going downhill. Those aren't perpendicular. So just plus or minus 1/2 is not enough. It's not just making signs opposite. The relationship really is that perpendicular lines have slopes that are two different changes, negative or opposites really, reciprocals of each other. All right, so there's like the long word definition. two lines that have slopes that are opposite signs, as in negative of each other. One's positive, one's negative, and reciprocals. So two changes have to happen for them to be perpendicular lines. And so I might say, oh, this one might have a slope of y equals 2x plus 3. I'm just making it up. All right. If this one is perpendicular, the slope has to have this, change this slope to its reciprocal and change the sign. So changing the sign is easy. That's negative. Reciprocal of 2 is think of 2 over 1 and flip it over, right? 1/2. And I made this go through -1. So I could look at those two equations now and say, oh yes, those two slopes are the opposite or negative reciprocals of each other. And this will be our technique for calculating or determining whether two lines are perpendicular or not. Now, the other sort of algebraic or mathematical relationship there, if I call one of them slope 1 and I call the other one slope 2, right? If I multiply those two together, I will always get -1, right? 2 times -1/2. Well, the 2's cancel, I get 1 over 1, and there's the negative sign. Right? So if you're looking at the equations, just recognizing it should be good enough. Here's just another way to calculate it and be sure. So, of course, you're going to run into similar to those parallel equation situations where they're going to hide one, not make it obvious. And sometimes they're going to make it neither. They want you to do the work, and then you realize, oh, one's 4/5 and the other one's -4/5. Oh, they have opposite signs, but they're not reciprocals. They're trying to trick you. So they've got to have both of those different changes. Both of those changes here. So, for instance, right? And a couple of examples I have on my notes here. See how this works out. Well, this one's in slope-intercept form. I can see it has a slope of -3. So one type of question that actually I think will be asked in MOM, what would a line that's perpendicular to this have to have for its slope? What does this one got to be if it's perpendicular? Well, I know this one, so what would be the negative reciprocal of it? This one, other one has to be opposite sign and reciprocal. Other one has to be positive 1/3. All right, this is 3 over 1. Flip it over. So if I can rearrange this one and figure out that its slope is positive 1/3, these two equations represent lines that are perpendicular. So let's see, solve it for y. I'm going to subtract this x from both sides. -3y equals, and I'll put the x first, -x plus 4. All right, now I have to divide by -3 to get the y alone, right? -3, -3, -3. Let me get this out of the way. So those go away. I get y equals, negative divided by negative is positive. Now this is x over 3, but I'm going to pull it out like 1/3 times x. And 4 divided by a -3 is a -4/3. Oh well, happens to be a fraction. We don't care. All we want to be able to do is look at the two slopes. And sure enough, this one is positive 1/3. This one is -3. They are opposite signs and reciprocals of each other. Two changes have to happen for perpendicular. So you'll be asked that kind of question, just what does the slope have to be perpendicular? And then you'll be asked to actually look at a couple of equations and determine from the equations like this, whether or not they are perpendicular. Oh, how about another one here? Whoops. Every day I do something like that. Whoops. All right, two more, huh? Two more equations. Are they perpendicular or parallel or nothing? That's kind of one type of question. Look at these two equations and put them in this shape so you can look at their slope and determine whether they're parallel because they have the same slope and different intercept, or they're perpendicular because they're negative reciprocals of each other, or there's nothing special about those two different slopes. They're neither. This one I know, slope is 2. This one I'll solve for y again. And leave the y's and subtract the x. 2y equals negative x minus 6. All right, okay. Divide by 2. Huh? Divide by 2, divide by 2, divide by 2. Y equals negative 1/2 x minus 3. Oh, okay. I picked up another one. It was, right? 2 over 1 and negative 1/2. Positive, negative, and they are reciprocals. They are perpendicular lines. Won't do that. Yeah. So, and I also just did discuss that if you have vertical, y equals 2, x equals negative 3. Well, one's a horizontal and one's a vertical. That makes them perpendicular, even if they're not the axes, right? Horizontal versus vertical. You have to recognize from those equation shapes that they are horizontal and vertical, and just when I say geometrically, they are perpendicular to each other. And I can't just compare the slope because there is no slope for that line. Undefined, right? Vertical is undefined. This one, is 0, but we can't use our other, method. Right? So that really was that new stuff that we didn't get to yesterday in this section 4.5. We started with a little review. There was just basically some presentation of, gee, now you have lots of choices for how to graph a line. That's often one of the first questions, at least when I used to write my tests for this chapter. Here's a graph, a blank graph, and here's an equation. Graph it. Pick your favorite way to graph this line. But, well, I'm really good at slope-intercept, and it's in that shape, so I'm going to do it that way. Or I'm not sure, so I'm going to build my table and plug in some points, x and y. Or it's in that shape using the intercepts. It would be really good for the ax plus by equals c. I'm going to use the intercept method. So, or I just recognize that that's a horizontal one. That's a vertical one. So you have choices. And then we discussed the relationship between parallel and perpendicular. That kind of gets us through our 4.5. All right. Again, I kind of apologize. Maybe you could tell I was a lot of it this morning. But if that's okay for us getting through the rest of that material today, I think I'm going to wrap it up for today and take it easy. And then tomorrow we'll start with section 4.6, where we start working with the information that we have and creating the equations ourselves based on the information that we're given. Okay? So if there are no questions or issues, I'm going to let you go for today, all right?
Thank you, Steve.
All right, you're very welcome, and thank you for understanding, and I hope that homework goes well, and have a good day. See you later.
Can I have this 1 second of your time, please?
Absolutely.
Thank you.
I'm sorry, who is that, Maria?
Yeah.
Yeah. All right. And we could wait to be alone, or Tara's hanging in there. That's right.
I'm here. Sorry, I had to run to the restroom.
I just wrapped it up, okay? But then I was going to kind of have a conversation with one of our other classmates. So we're done for today. I'm sorry.
Okay.
See you later.
Thank you.
You're welcome.
Hi, Steve.
Hi, you're alive.
I am, and I'm plugging along.
Good.
If that's
Well, you
okay.
sound good at least. Yeah. I do appreciate you sharing all that information with me on that message, that email. It's more than is necessary, but I understand, and it's no fun being sick, and of course the personal loss of your friends. Not lost, but I understand, her situation. I actually had a friend. Well, she came through okay, but just about 2 weeks ago now, had a tumor removed. Most of it removed. Also had to go through something very similar. Luckily, I guess for her, they didn't get it all, but she's going to be okay. So
That's wonderful news. That is. At this point, there's nothing else we can do, and this is plateaued, and I'm just.
you're talking about your health situation, right?
No, my friend. She's just,
Yeah.
she can't speak and she's paralyzed, but this is it. So now we just have to move forward with our lives. And so I'm present, and I did a lot of, I think 4.5 yesterday.
I noticed, or maybe
4.3, something like that, anyways, but I'm present and I'm doing it, and I'm just doing the best I can and
I'm
staying.
as flexible for you as you need. Okay, you understand that, all right?
Okay.
It's just kind of good for you to keep in touch with how you're going. I check the grade book several times, probably every day. It's like, how are folks doing? Are you getting through this work? I think I wrote you a message this morning in Mom, just some comments based on some errors I saw in the couple things you missed in 4.1, the homework where you're,
Okay.
plugging in notes. And I try to actually address that sort of indirectly when I talked about plugging in the zeros. That.
Yes. Yeah. And I want to show you, I don't know if I can get back online here, but I take really excellent notes. I've got graph paper, and this seems to be easier for me than some of the other math that we've been through. But yesterday when I wanted to take my test, I thought it was yesterday, but it was in fact, so the system locked me up, so I can't do any of my homework. I want to go back and do homework but it won't let me click on anything to do it.
Maybe you haven't looked since you sent that. I thought I went in yesterday after that, and I basically extended the test another week, and any of the current chapter homework, I extended that also.
Thank you so much. Because that's why I started at 4 point whatever, because that was the only thing that it could let me do. So I thought, well, I'll just start there and just get something in, so it looks like so you could see I'm present.
Yes, well, I appreciate that. I understand that. You're trying. I'll go back. I thought I was trying to make sure that last week's homework was still available to you. But if I'll go back in later today and look and make sure that even some older stuff, if you're still gonna, you still need to try to get through chapters 2 and 3.
Yes.
I'll make sure that that's still available to you.
Yes.
Okay?
Yeah.
Do the best you can, and we're I say we because RCC, we're pulling for you, and we'd like to, you're trying, and it's not like you're flaking out or anything. We're going to do what we can to help you. All right.
Okay. I appreciate that so much.
And I hope you maybe you saw my reply eventually. I did pass along your situation to Andrew Childress, if you know who that is. He's the head
He's
of
the disability guy?
he's the head of the disability services. Yes.
Yeah.
I was just saying, hey, I've got a couple students that are having trouble, and I noticed they both had accommodations, so I contacted him, and I basically shared your situation with him, so that if there was anything on his end he could do to help you, perhaps specifically with the program requirements that you're concerned about, he's in the loop, and he actually has said he's tried to reach out, contact you just to see how you're doing a couple times. But I shared that letter that you sent to me, and I shared it with him too, just so he knows what's going on. So it's all designed to help you. I hope that's okay.
Thank you. And I haven't looked if how would he have done that? Like called me? Because I don't know. I haven't gotten a phone call, and if he emailed me, I haven't been in my emails.
I'm not sure how he would have done that.
I'll check that out. And yeah, and you know what I talk about isn't confidential. It's just I just worry about me. Like I said, I don't want to say too much to anybody because I seriously got thrown out of the massage therapy program because my brain, you know, and my surgery and the learning disabilities that I was having, and like one teacher in particular, it was awful what she did to me, and I went up against the administration, and they didn't take my side, and I don't have the support of them, so it's really just I just want to get through it and not. But my son said, you're having difficulty with math, you need to tell them, and that doesn't have anything to do with the massage program, and have them help you. So here I am.
Yeah, well.
And as far as the massage therapy program, I can't, they won't let me just have any more excuses or anything. So, but with math, it's so hard for me. I don't know why my brain doesn't work that way.
I've heard, let's say, horror stories about students in other classes and the policies and procedures that some teachers have, like, you know, locking the classroom door if you're late. They just close the door, or not
really
the way it works. Not the way it works.
It's been an awful experience for me. Like, I had some trauma in 3rd grade, and I felt like I was back there again because of what I went through. And I told the administration, and nothing happened. So I understand, you know what, hey, yeah. I'm not going to deal with RCC anymore. I'm just going to go into my classes, get them done. But the math it's just different because it's like, oh my gosh, I need help with this.
Well, I hear you, and that's kind of why we're here and teaching these kinds of classes, you know, because you might say hurdles or stepping stones you got to get through to get to where the program you want to be in needs you to be, and so yeah. We got to try and get you through this level of stuff so you can get to where you want to go eventually. You know, well, continue to share your stories as much as you're comfortable with me. I think I'm aware of a nice thread of folks at RCC that I contact, you know, that they're here to help. So anyway, I don't think you run into those kinds of problems online.
Yeah, it was one teacher in particular. It was
oh well.
Okay, and she wasn't like any other person at RCC. She's just an isolated person that is just, and other kids are terrified of her, and it just doesn't matter. They won't do anything, and that she's still my teacher. So I have to just face that. But as far as, you know, the administration part wasn't on my side, but the teachers, I've had amazing, wonderful teachers, the best experience, the financial aid people, the counselors, like across the board here at this campus and in Grants Pass, Medford. I mean, just wonderful. But the administration at the top didn't have me, so I don't trust it. I'm just trying to do the best I can and just not say anything and get through it and be done with it. Just get what I need and no.
I know that way too.
You know, sometimes you just gotta do that in life and just be like, you know what? Fine, I'll just do this. Yeah. But thank you, and I will look for Childress.
Oh, Andrew. Yeah, Childress, whatever. I think.
Andrew.
Yeah. And what do they call it now? Access and Disability Support or something like that. They've changed Disability Services name a little bit, but yes, he's the I think the manager director of that.
Okay. Well, I'll see what he has, something that can help me with math or something. I don't know.
Not sure he have really specific suggestions for helping you with math, but more so maybe with helping you with requirements, or maybe, I mean, if it came to it and you couldn't complete this course, he, maybe could be on your side and helping you to continue with your program. I'm just guessing. I have no idea. Yeah. That's kind of why I contacted him. So.
Thank you. Yeah.
All right. Well, Maria, always send me messages and emails and ask for help, and I'll do my best.
Okay. Thank you so much, Steve.
Okay. Well, you're welcome, and best of luck to you. And maybe see you tomorrow, right?
Yes, and get better. Get some rest.
Yes, thank you. Right. Take it easy. Don't want to catch you know what. Yeah. Well, good enough for now then.
Have some tea and relax. Thank you. All right. Take care.